This video reviews how to calculate the energy of temperature change using specific heat. By the end of this video, you should be able to explain what specific heat capacity is and be able to do calculations using the Q equals mass times specific heat times change in temperature equation. So specific heat is the amount of energy that must be transferred as heat to raise the temperature of 1 gram of a substance by 1 degree Kelvin. Note that this could also be 1 degree Celsius because the size of degrees in both Kelvin and Celsius are the same. The general term used for specific heat is a lowercase c. The units for specific heat are usually joules per gram times Kelvin. You might also see joule times gram times degrees Celsius. The key point here is that specific heat capacity is individual for each substance. In other words, different substances have different specific heats. Here's our equation that we're going to use to calculate how much heat is either absorbed or released during a certain temperature change. If you know the specific heat of a substance, you can go ahead and calculate this. So here's our example. A 100 gram sample of water was heated and the temperature increased by 10 Kelvin. How much heat did the water absorb? So first we can write down our equation, Q equals mass times specific heat times the change in temperature. And then we want to annotate the problem. We have 100 grams, that's mass. We have a sample of water, so we need the specific heat for water. We look at our table of specific heat values and we get 4.18 joules per gram times degree Kelvin. And the temperature increased by 10 K, that's our change in temperature. And then we just go ahead and fill in our values and multiply to find our answer. It's important that you see that we can cancel the units of Kelvin and grams so that the units on our answer will be joules, and that's our unit of heat energy. So our answer for this problem is 4,180 joules because we multiplied 100 times 4.18 times 10. So 4,180 joules of heat were absorbed. Here's our next problem. A 10 gram sample of aluminum was heated from 300 Kelvin to 325 Kelvin. How much heat was absorbed by the aluminum? So again, we can write down our equation. Q, which is the heat energy measured in joules, equals the mass in grams times the specific heat times the change in temperature. A 10 gram sample, 10 grams is our mass, of aluminum. So C is going to be the specific heat of aluminum, which is 0.897 joules per gram times Kelvin. You would look that up in your data table of specific heats or wherever you have your specific heat values. Our temperature goes from 300 to 325. So this is a positive change of 25 degrees Kelvin because it went up by 325. How much heat was absorbed by the aluminum? So we plug in our numbers, 10 grams times 0.897 joules per gram times Kelvin times 25 Kelvin. We can cancel the values, units of grams in Kelvin. Multiply, and our answer is 224.25 joules. That's our Q. And again, this is heat absorbed. We know it was absorbed, one, because the question tells us, but also because the temperature increased. And it requires heat energy in order to increase the temperature of something. Here's our next example. It says a 0.5 gram platinum ring was dropped in the snow, and its temperature dropped from 35 degrees Celsius to 0 degrees Celsius. How much heat was released? So we can go ahead and annotate. So 0.5 grams is mass. Platinum ring, we need to look up the specific heat for platinum. It's 0.133 joules per gram times Kelvin. It was dropped in the snow and its temperature dropped from 35 to 0. So going from 35 to 0 is a negative change because the temperature is going down, and it's going down 35 degrees. And you might be asking right now, do I have to convert from Celsius to Kelvin? Well, you could convert from Celsius to Kelvin, but it won't make any difference with regard to how much the temperature changed, because the size of a degree in Celsius is the same size of a degree in Kelvin. And if you don't believe me, you can test it out. Do the problem by just subtracting here 35 from 0, and then try it again after converting both temperatures. See what you get for your change in temperature. All right, so how much heat was released? The fact that it says how much heat was released indicates that this is an exothermic process. Temperature is going down, and our value that we get as our answer is going to be a negative number. If you have trouble working with negative numbers and you would rather use the absolute value of your temperature change, you may. But if you do that, you need to use a description after your answer indicating that heat is released. So let's go ahead and set this up. We have 0.5 grams, 0.133 joules per gram Kelvin, and negative 35 K. When we multiply these together, we get negative 2.3 joules. And we can leave this as our answer. Again, the negative side indicates that heat was released. If you don't like working with negatives, you can use the absolute value, but then you would write 2.3 joules of heat were released. So either one, this is an or, so you would do this one, either one of those answers. I hope that was helpful. That's the end of our lesson. Have a good afternoon.